Okay, well, as promised, let's wrap up day 2 of our 5-day CCDA bootcamp here at INE by wrapping up this second module. And, no, the third module, third module, excuse me. We had module 1 in this course where we looked at the Intelligent Information Network and Cisco SONA. We had module 2 where we looked at the Cisco hierarchical network model, and we took a look at the enterprise architecture model from Cisco. And then here in module 3, we've been focusing on our various LAN components in order to build an enterprise campus local area network. And in this wrap up of module 3, we'll go ahead and talk to you about best practices that we can utilize in these local area networks. And we'll also talk to you about the fact that one size doesn't necessarily fit all, that there is definitely going to be some variation in the technologies that we use and the overall designs that we use based on the size of the local area network infrastructure. But there are definitely best practices we want to start with here first and foremost. Definitely the most important information in this lesson. We want to make sure we fully understand all of the best practices that Cisco lays out for us regarding these different areas of the campus LAN. And by the way, notice that we are talking about here that 3-layer hierarchical model that we know that can exist in the campus LAN. That's, of course, that 3-layer access model, followed by the distribution area or distribution block, and then the core. So here we're going to break down the best practices into that 3-layer hierarchical network model that we know fits right into the campus LAN. With quality of service at the access layer, there are definitely going to be best practices that we use to make sure performance of the traffic forms is going to be followed not only in the access layer, but in the distribution and core layers. Remember what we said regarding quality of service in the access layer? This is typically where we're going to be doing our classification and marking of traffic for sure. This is definitely where we'll classify and mark traffic. But also, we'll be typically engaging in congestion management approaches here as well. Congestion management can ensure that if a particular layer 2 switch is experiencing contention, in other words, there's a lot of different traffic forms that are trying to get through the layer 2 device, congestion management can ensure that the traffic is properly prioritized as it is moving through the layer 2 infrastructure. So we tend to find always classification and marking done here. We tend to find congestion management done here as well. And also more and more, we're finding congestion avoidance being done down at the access layer. Congestion avoidance says, you know what? We're going to go ahead and drop unimportant packets. We'll drop unimportant packets to try and avoid congestion if the layer 2 device is nearing a point of congestion. Why wait for congestion to be a big problem in the network? Why not proactively head it off by throwing away unimportant packets and ensuring that our important voice packets, for example, get through? Earlier in the lessons today, we did a lot on redundancy. So earlier here in day 2 of the CCDA bootcamp, we talked a lot about redundancy, and we're certainly going to be building as many redundant links and as many redundant devices as our budget can afford at the access layer. Earlier in the lessons today, we talked about geographical limitations on the scopes of your VLANs. And that is the popular methodology today. So our VLANs end up looking like, first floor west, first floor east, second floor west, second floor east. And we are limiting the VLANs to a single closet in the infrastructure. This is a change from how things used to be done. Things used to be done with more of a functional approach to the VLANs, but keep in mind, that's when we used to follow the 80-20 rule of networking. So functional organizations of the VLANs made sense back then because 80% of your traffic back then stayed within like your department, But now we're finding that 80% of the traffic goes out to the internet or out to other non-local resources. And that's when it really made sense to go ahead and organize your VLANs based on just geographic location. Now, spanning tree protocol. Spanning tree protocol is definitely wrought with inefficiencies. But we can't just say spanning tree protocol anymore. We have to be much more specific. We have to specifically say that we're talking about classic spanning tree protocol, and that is the 802.1d technology. Classic spanning tree protocol is indeed wrought with inefficiencies. The main problem with classic spanning tree protocol is the fact that it operates based on timers. The timers, by the way, are known as the max age timer and the forward delay timer. These timer values can literally make as long as 50 seconds for convergence when there is some change in the topology. We know for a fact that 50 seconds, that's like an eternity. That's like an eternity in networking terms. 50 seconds of downtime in today's intelligent information networks, that is far, far too long a duration to have this delay. So the classic spanning tree protocol has been replaced with rapid spanning tree protocol. In fact, I messed it up here, didn't I? That's spanning tree protocol, STP, not SPT. So rapid spanning tree protocol, it breaks this reliance on timers. It eliminates the reliance on timers, and it dramatically speeds the operation of the protocol. It's now what's called a proposal and agreement process that takes place between the switches, and the switches all have to be configured, point-to-point full duplex in order for this to work. But that's no problem because that's what we would have set up anyways. And this rapid spanning tree protocol, known as 802.1w, this is a technology that we most likely want to target. This, used in the access and distribution layers, is going to dramatically speed things up. By the way, Cisco had created port fast. They had created uplink fast. They had created backbone fast. They had created all of these technologies to try and enhance classic spanning tree protocol. And sure enough, all of these technologies get implemented in rapid spanning tree protocol. Uplink fast, built right in. Backbone fast, built right in. And port fast in rapid spanning tree environments, you still configure. So you're still going to configure port fast. But uplink fast and backbone fast, you don't need to worry about configuring in a rapid spanning tree protocol world. They're just going to be operating, they're just running by default as part of the protocol. Their functionality is now built in to the protocol. Now, this is a very interesting recommendation from Cisco. I suppose we better memorize this for the purposes of the certification exam, but I don't necessarily agree. As a matter of fact, many of our engineers in the audience today won't necessarily agree with many of these recommendations that we're getting from Cisco. We kind of have to take them with a grain of salt. Notice that Cisco says that we should use the dynamic trunk protocol, and that specifically we should set the links to desirable and desirable. Now, many of us look at this and we say, geez, no thanks. We're going to set the trunks to on mode, and we are going to set the trunks to not use DTP. So this is probably a more common recommendation, but we better know for the purposes of this course, the desirable and desirable options are the Cisco recommendation. So Cisco's saying, go ahead and use DTP. Don't turn it off. Just make sure your links are set up to desirable and desirable mode. I would prefer using the command switch port mode trunk and the switch port no negotiate. So I would turn off DTP and set the modes to on, but that's just my real world recommendation. For certification, we'll go with their desirable recommendation. Notice it's interesting. Cisco says, okay, let's go in and manually prune any unused VLANs off of trunk links. Notice they're not saying use VTP pruning. In fact, they're telling us to turn off VTP. How do we turn off VTP? We go in and we set VTP transparent mode on all the devices. So here, as part of the best practices for the campus LAN access layer, Cisco is telling us, look, let's manually prune VLANs from trunk links where they're not needed, and let's not do it with VTP pruning. As a matter of fact, let's turn off VTP altogether through the use of transparent mode on all of our devices. But this isn't the only recommendations they give us for the access layer. They tell us that with our access ports, we should disable their ability to trunk. So we go to the access ports and we say, no, 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 don't ever potentially become a trunk. This is done, of course, with the switch port mode access command. And yeah, that's how you can type it at the command line. SWMOACC. Switch port mode access. That's the common abbreviation, and that disables the possibility of trunking for that particular port. Yeah, and already, by the way, someone in the audience is definitely surprised. We've got Yasir, my good friend. Yasir is in the audience, and he says, are you kidding me? Turn off VTP? Yep, absolutely. That is not a mistake. That's the recommendation. Cisco says, don't use VTP, and you do want to prune VLANs, but manually prune them by using the switch port VLAN or switch port trunk allowed VLAN configuration. One of the reasons that they recommend turning off VTP completely is, I'll tell you one of the big reasons, is that before VTP version 3 came along, and the CCDA course was completed before version 3 of VTP, you have to understand that Cisco is really concerned about security. They are concerned about the malicious or accidental overwrite of the VLAN database thanks to VTP. So one of the reasons we're seeing them recommend VTP be turned off here is the fact that the security risks are too big. The other reason that they're recommending the turning off of VTP here is because if you build the network in a real hierarchical, modular fashion, there's not going to be that large a VLAN database anyways. So the more hierarchical, the more modular you make your network, and that's what we've been stressing in this course, is building hierarchical and modular networks. You're not going to have this massive VTP database anyways. So again, we'll take these recommendations, we'll memorize them for the purposes of certification in this case, and then obviously these are not like hard and fast rules. Cisco is going to tell you to consider the use of routing between devices in the access layer, between devices in the distribution layer, between devices in the core layer, as much as is practical. So where practical, we want to set up routed connections between the devices. If we set up routed connections between the devices, this guards against any convergence inefficiencies that we might have to contend with spanning tree protocol. Also, when you're using routed connections between your devices, you can start to do the sophisticated load balancing, and you have your fault tolerance mechanisms that the routing protocols provide. Get to start taking advantage of the remarkable load balancing and fault tolerance capabilities of something like the Enhanced Interior Gateway Routing Protocol, the IGRP. So whenever practical, they want us to start considering layer 3 routed connections between these devices. Remember, we always want to use Spanning Tree Protocol's PortFast feature. We always want to use PortFast, and that's including if we are in a rapid Spanning Tree Protocol environment. Remember what I said, PortFast, we are going to configure it in rapid Spanning Tree Protocol environments. You know, something else, the last recommendation we get here from Cisco regarding the LAN access layer is a command that is often overlooked. A command, pretty nifty command that's often overlooked in Cisco courses. It's this cute little macro command called the switch port host command. Let me go ahead and show you this command and show you what the switch port host command does. As we can see here, it's the last of our best practice recommendations regarding the access layer of the campus LAN. You can go to a switch port that's going to connect to a workstation, let's say interface fast Ethernet 0/10, and you can say switch port host. And what does it do to your port? It sets the mode to access, something that we said was an earlier best practice. It sets spanning tree port fast. Great, another best practice. And it disables any attempt at channel grouping. So what happens here is this port becomes a strict single access port for the connection of a typical run-of-the-mill like Windows or Mac computer or Unix-based computer. Pretty cool. So if you do show run interface fast Ethernet 0/10, we see it did switch port mode access, it did spanning tree port fast under the link, and it removed any channel group. There wasn't any channel group on the interface, so it didn't have to do anything there. Now keep in mind, if you say no switch port host, it cannot undo those kind of automatic settings that it just put in place. So watch out for that. No switch port host will have no effect. You would have to go ahead and exit back to interface configuration mode and say like default interface FA 0/10, and that would effectively undo the switch port host command that you utilized. Pretty cool little shortcut command there for setting up interfaces to be connected to plain old run-of-the-mill workstations like we so frequently have to do in our LAN infrastructures. Well, let's go ahead and transition into a discussion here about best practices for the distribution layer. As we talked about earlier today, we definitely are going to often consider aggregating bandwidth together into an ether channel. This is important at the distribution layer because we know we have to provide support for the aggregate access layer bandwidth. We typically have quite a few security mechanisms and quality of service mechanisms that also need to be enabled in the distribution layer. For QoS, it can be just about all of it. You know, when we talked about QoS on day one, and I told you it was many components like congestion management and classification and marking. Okay, so we've got, you know, congestion management, classification and marking, congestion avoidance, policing and shaping, link efficiency mechanisms. I mean, a lot of these different QoS mechanisms, a lot of your different security mechanisms, they are going to be implemented at this distribution layer, at this key layer where we do a lot of policy enforcement. Something else we covered early today on day two, we talked about all the different flavors of those first hop reachability protocols. So your HSRP, your VRRP, your gateway load balancing protocol, these are typically going to be implemented at this important distribution layer. Once again, we want to consider layer 3 connections between the distribution layer. At the very least, you want to consider layer 3 between the distribution and core. This is going to enable you to take advantage of the load balancing and redundancy capabilities that are built into your sophisticated routing protocols. We talked about how much we love summarization, and summarization is definitely something that you want to engage in typically from the distribution to the core. So we can hide from the core details of the subnet information by aggregating, by summarizing the TCP/IP subnet information before sending it to the core. Notice also that we want triangles, not squares, built between the various blocks in our network. What do we mean by that? Well, if you look at your nodes, if you look at your network nodes, right, you don't want to connect nodes. Let's say the top two are the distribution layer, the bottom two are the core layer. You don't want to connect the nodes in a square like this. Notice that's not giving us the robust fault tolerance that we would want or need. You want to go ahead and make triangles when you're connecting these devices. And this, of course, refers to your more full mesh configurations. Okay? So we want to go for the redundancy that the full mesh triangular type configuration would bring us to. Okay. How about the core? Well, in the core, not a lot going on, right? The core is all about simplicity. It's all about speed and simplicity. Of course, we need redundancy, so we're going to design those triangles into the interswitch links that we have there in the core of the network. Again, we're thinking about layer 3 connections where possible to take advantage of the fast converging layer 3 protocols. And it's typically high-end multi-layer switches, but it always doesn't have to be, okay? In actual practice out there today, you see really two main approaches in the core. You see either a layer 2 or you see a layer 3 core approach. So you've got either high-end layer 2 switches, okay, or you've got your layer 3 multi-layer switches using a routed design, using routed links as opposed to the layer 2 switch link approach. Both approaches are found today. Notice that in CCDA, Cisco is stressing more of a multi-layer switched layer 3 type approach. But I just want to forewarn you that you still will see the earlier style layer 2 core networks as well. But I began this whole section by reminding you that, of course, not all LANs are created equal. I mean, certainly your overall network will incorporate sites like I'm speaking to you from right now. I am definitely in my small office, home office, which would be considered definitely a small, remote site local area network. I have a very small Cisco router, which connects to a WAN. And this very small Cisco WAN router connects to my local area network via a small switch. So we've got the small router connecting to the WAN, which then connects to the LAN, and I've got a small switch which creates my local area network. This router, by the way, on my network provides DHCP services for my small site local area network that consists of, let's see, I have an 8-node network. 8 total nodes that this DHCP server fulfills IP configuration requests for. By the way, obviously you might not even have a DHCP server. Your router may act as a DHCP proxy, forwarding on the DHCP requests upstream. So certainly things can be very, very small, and you don't have this concept of an access layer, a distribution, and a core layer. Everything collapses down in the small remote site LAN to just one big functional layer that does everything. In a medium site local area network, we typically have anywhere from 200 to 1,000 devices. And notice there is a collapsing of the layers, but it typically involves just the distribution and core layers that collapse. So the distribution and core collapse, and then you've got your access layer sitting on top of the collapsed distribution and core. Moving up from this medium-sized LAN, we encounter large building local area networks. These are typically segmented into VLANs, and that segmenting occurs by floors and or departments in the organization. Here we typically have simple, low-cost layer 2 switches at the access layer, and then layer 3 switches in the distribution and core. And sometimes in the large building LAN, we have a collapsing, once again, of the core and the distribution. Moving up from the large building local area network, we have the largest structure that we identify in this course for LAN. It's the enterprise campus LAN. It may feature gigabit or 10 gig connections between multiple buildings. Once again, layer 2 devices are used at an access layer, and then gigabit capable layer 3 switches are typically found in the distribution and core layers. Connected to this enterprise campus LAN, to review from day 1 of our course, connected to this enterprise campus LAN, we have an edge distribution module. The edge distribution module is to obviously give us connectivity to WAN and internet service provider services. So this enterprise edge distribution module, very, very important so that the campus LAN has connectivity to all of the wonderful remote resources that we need to access. Something else that's beautiful about this edge distribution module is it's a perfect place to add additional layers of security between the outside world beyond the enterprise edge and our very, very important campus LAN. The additional security that we add here in the enterprise edge can guard against IP and MAC address spoofing attacks. Oftentimes, IP address and MAC spoofing are an attempt to gain unauthorized access to LAN resources. Security in the enterprise edge can also guard against network reconnaissance attacks. Here's obviously one of the reasons you would want to turn off CDP in the enterprise edge. You don't want to advertise out to the untrusted world details about your Cisco network infrastructure. During a network reconnaissance attack, a computer criminal is coming in trying to map out your network. They're trying to create a map of your network, its layout, the addressing, the devices you use, so they can enact further attacks against your infrastructure. We can also guard against good old-fashioned packet sniffers in the enterprise edge module that are trying to come in and detect clear text, data, and passwords that are being sent in your network infrastructure. Smaller enterprise campuses might feature a server farm. Inside the server farm, which is a collection of key server resources, you'll typically find gigabit or 10 gigabit Ethernet connections. Obviously, Ether channel is important if these connections need to be aggregated. And one thing we always tend to find is redundancy to the core. I mean, we need redundant connectivity to the core so that these key resources in the server farm are always accessible. Servers might be connecting via the server farm via single network interface connections, or that NIC teaming we talked about before, where a server literally forms an Ether channel with its local switch to provide even greater bandwidth. The most sophisticated approach, though, is to engage in content switching. To have these very high-powered switches that connect to the server farm devices, to have these go ahead and pull the content off of the servers and have the switch cache the content and serve that content up to the core layer of the infrastructure. So you can have these Cisco devices pull these file resources and web resources off of the servers, store them in a fast-acting cache, and serve them up upon request. But for large, sophisticated, complex enterprises, a server farm module might not be enough. And the enterprise may engage in what is called a data center infrastructure module. So it may have a sophisticated data center module that is running network infrastructure and network service layers of the service-oriented networking architecture model. So there can be this complex equipment and these complex services like virtualization to make a full-blown data center available in the enterprise. Here we typically do indeed have very high performance gigabit access layer connectivity, including that NIC teaming where we've got these big, robust servers that are connected via ether channeled connections, and the connection at this access layer of the data center may be in the gigabit per second speeds. As you know, what is very, very popular today is clustering or virtualizing the servers that are in this data center. I mean, the servers are clustered in such a manner where if one fails, the others transparently do the job of that failed device. And we can go in and we can hot swap networking equipment without causing any disruption whatsoever in the network. Obviously, exciting technologies here, and this is a growing area of Cisco's certification program and Cisco's expertise. By the way, the aggregation, the distribution layer here, the distribution layer of the data center, it gets typically a fancier name. They call it the data center aggregation layer. And there's all kinds of technologies that will be used here, like sophisticated load balancing equipment, secure socket layer offloading devices. Since everything's wanting to come in and get information from the data center over secure connections, you literally need equipment that's specialized to really quickly deal with all this secure socket layer VPN connectivity. We typically have very sophisticated adaptive security appliance firewalls. And on day one, we talked about intrusion detection and intrusion prevention systems. And these are certainly relevant for the enterprise data center. Well, to wrap up our discussion of Module 3, our discussion of from small LANs to huge LANs, we want to go ahead and talk to you about multicast controls in your infrastructure. We haven't really talked too much about multicast at all in this course, and Internetwork Expert is proud to be releasing next month in September of 2010. September of 2010, INE will be releasing a 3-day boot camp dedicated to multicast. So we're really excited about that boot camp. But anyways, we need to remember that when it comes to multicast in our environment, how host systems report to their local router that they want a multicast feed is utilizing IGMP, the Internet Group Messaging Protocol, IGMP. And there are currently versions 1, 2, and 3 of IGMP, although the standard, the default that you find out there is version 2. Version 3 is for something called source-specific multicast, where the client gets to say, you know what, I want to get the multicast data, but I only want to receive it from server A, for example. So with source-specific multicast, the device can be very, very specific about who it's going to get the multicast traffic from. Like I said, the default version that we have today of IGMP is version 2. We turn on IGMP version 3 if we have a need to do source-specific multicast. But what's really interesting here about this discussion is how do we constrain the multicast traffic when it comes to our LAN? And this is a really interesting question because we remember what a switch will do by default with incoming multicast. It will flood it out every possible port. It floods it out every port that's in that VLAN. So when multicast traffic comes into a switch, by default, it gets flooded out all the ports that are participating in that VLAN on that switch. Yikes. How can we make the switch, how can we make it respond? How can we make it control much better the forwarding of the multicast traffic? Well, you've got two options. One is quickly fading out of utilization. Cisco is trying to kill it. It's a Cisco invention called the Cisco Group Management Protocol, CGMP. And what happens with CGMP is you've got a router on the network, and it communicates using these CDP messages with the switch. So the router and the switch send these CDP messages back and forth. Gosh, we don't want the overhead that CGMP incurs. We don't want to add another protocol that the router and the switch need to communicate with each other in order to provide this info. There's a much cleaner, better, more efficient way to go, and all Cisco switches are supporting it now. In fact, on new Cisco switches you buy, you won't even get CGMP. The better approach is IGMP snooping. After all, I mean, here's your situation. You've got a host plugging into the switch, and then that switch is going to plug into a router somewhere. So the idea here is when the host says, you know what, I want to join a certain multicast group, and it of course does this by sending an IGMP message, just have the switch eavesdrop on this IGMP message and filter out the traffic for the particular port that wants it. So thanks to IGMP snooping, the switch will eavesdrop on the IGMP messages, figure out what ports are appropriate for what multicast groups, and then intelligently filter this information. Sure enough, Cisco engineered application-specific integrated circuits to make all of its switches now adept, make all of its switches very good at performing the IGMP snooping function. Before there was this special hardware for this purpose on the switch, well, CGMP was actually a more optimal way to do it. But now that the switches have been built with IGMP snooping in mind, There's absolutely no need for the overhead of the CGMP protocol any longer. Wow. Great stuff. And that wraps up our third module of our CCDA course. And that wraps up what I had planned for you here in day 2. Tomorrow, in day 3 of our CCDA bootcamp, we pick up with looking at the wide area networking enterprise edge. So we're going to go out to the enterprise edge, and we're going to examine the various technologies that we will find in the WAN. Obviously, we're going to spend a lot of time talking about proper designs that you would have in the wide area networking components of your network infrastructure. After talking about the wide area networking infrastructure, we then transition in this course to discussing IPv4 and IPv6 addressing designs, and we'll get into an intense discussion about picking the right routing protocol for your environment and designing the individual routing protocols properly for the most scalable and efficient networking possible. More great fun coming up in our CCDA course. But before we wrap up, a review question that asks us to name at least 3 best practices for the access layer of the campus LAN. Well, there was 3 that jumped out at us. Them telling us to turn off VTP. That certainly jumped out at us. And to manually prune VLANs off of trunks where they're not needed. And finally, one that really jumped out at me, with your access ports, at the very least, use the switch port mode access command. And the switch port mode access command will ensure that the that the switch port cannot be a trunk. So where we want to plug in workstations, we turn off the ability of the port to trunk. Certainly 3 recommendations that we saw from Cisco for the access layer of our campus LAN.